Okay, so we have the standard form of a quadratic equation. 0 is on the right. It's an equation because it contains an equal sign. A is the leading coefficient. It's the coefficient of the highest degreed variable, right? Quadratic term. B is the coefficient of the linear term, and C is a constant. And what we're going to do is we're going to derive the quadratic formula because it's worth knowing how to do it. And in fact, you already know how to do it because you know how to complete the square. And that's exactly the method we're going to use to derive the formula. So if you remember with completing the square, the first thing we do is we move our constant over to the other side. We're going to do that using the inverse operation of subtraction. So we've got ax squared plus bx is equal to negative c. So I'm leaving myself some room there. Okay. And then, because we don't know what a is, if a is a 1, well then I don't need to do this step. But when a is any number other than 1, I have to remove it. I have to get it out of the way temporarily. So what we can do, an easy way to do this, is to divide every term both sides by that leading coefficient. So I'm going to do that. Okay. And over here, the a's are going to cancel. So what we're left with is x squared plus b over a times x is equal to negative c over a. Now I'm just writing this in this form. This is the same thing as this. If I multiply b over a times x, I get bx over a. These are the same, but what I'm trying to show you is that this here is a number. B over a is a number, and c over a is a number. Okay, so these are just two numbers. One of them is multiplied to x, one of them stands alone. Now that the left side is prepared, we can complete the square. We need to take half of the linear term, square it, and add it to both sides. Well, what's half of b over a? Well, that's easy. It's a different color here. I'm going to work on this side. What is half of? The word of in math means to multiply. So half of a fraction just means 1/2 times that fraction. And remember, when you're multiplying fractions, you multiply straight across in the numerator. So 1 times b is b. And straight across in the denominator, so 2 times a is 2a. So what I know is that half of my linear term now is b over 2a. And I need to square that and add it to both sides. Now remember, on the left, I don't square it. And I gave you the reasons for that before. Because what you're doing on the left is you're creating that perfect square trinomial. And so it's easier to see what factor to put into your binomial that way. But on the right, I do need to square it because I'm going to have to combine it somehow with this number. So if I square the numerator, I get b squared. And if I square the denominator, remember you have to square every factor. So 2 squared is 4, and a squared is a squared. Okay? So on the left, I've got my perfect square trinomial. So this is going to simplify to x plus b over 2a, the quantity squared. Now on the right-hand side, it's not so simple because I have two unlike fractions, right? My denominators are not the same. They're unlike fractions. So in order for me to combine, add, or subtract the numerators, my denominators need to be the same. So to do that, what I'm going to do is multiply this fraction here by an equivalent fraction. In other words, I'm trying to make this denominator look like this denominator. Well, what's missing here? A 4 and another a. So if I multiply up and down by 4a over 4a, like so, remember this is a product, okay? Then what I get is 4a times negative c gives me negative 4ac, and in the denominator I get 4a times a is 4a squared. And I'm just going to bring this guy down here to show you that now my denominators are the same. So I still have some cleaning up to do on the right-hand side, so I'm just going to rewrite this over here. And over here, I'm going to clean it up. Since my denominators are the same, I've got this common denominator, 4a squared. And now I could write this as negative 4ac plus b squared, but rather than that, we don't like to write numerators with the negative hanging out, so I'm just going to rearrange and write it like this. At this point here, now we have to take the square root of both sides to remove this square. Remember, we're trying to solve for x. That's always the quest. And so we're going to take the square root of both sides, but do not forget that on the right, you have to add your plus and minus sign, okay? Because there's two possible answers. And on the left, the index of this radical, which is 2, matches the power, so they're going to cancel, and x plus b over 2a is going to come out. Now over here, I want you to be careful again, because what we have is a fraction underneath a radical. And if you recall the rules of radicals, so over to the side again, rules of radicals say that we can put the numerator in its own radical, and we can put the denominator in its own radical. And what I notice is that I can't do much with the numerator of that thing. In fact, I can't do anything at all, but downstairs here in the denominator, I know that 4 is a perfect squared and a squared is a perfect square. The square root of 4 is 2, and the square root of a squared is a, so I can get rid of that radical. So what I'm really left with on the right is plus or minus the square root of b squared minus 4ac all over 2a. Now I'm not done yet, because on the left, x is not isolated, it's not by itself. I need to take this little fraction here and move it over to the other side. And how I'm going to do that is through subtraction. I'm going to subtract it from both sides. So we're going to have x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And I've got like denominators here, which is nice. And so I can write this over the common denominator. So I've got 2a here. It's negative b plus or minus the square root of b squared minus 4ac. And that, my friends, is the quadratic formula. Now we need to figure out how do we use it.